On to yet more formulas. Now we're on to the double angle formulas. Take the time to write these down. We'll go over in class tomorrow how they're derived because they're pretty easy to derive them. Okay, now that you've taken the time to write them down, please note here that cosine has three different ways to find the cosine of a double angle. And yes, you will be required to know all three. Of course, once you know one, you can derive the other two quite easily. So what the video will be about is, well, how do you use these? Again, it's all just playing with your algebra skills. No, the goat's not coming. All right. If we were told the cosine of some angle is negative 24 over 25, and it's in quadrant 3, then given that information, we want to find the sine, cosine, and tangent when we double that angle. Now, there's a couple of ways to do this. First is the straight-up algebra way. Negative 24 over 25. So cosine is in take 3, restart now. Okay, first thing we're going to do is we're just going to use our good old friend the unit circle because they told me quadrant 3. So when they tell me quadrant 3, I know I have to draw a unit circle, and here it is. Cosine is 24 over 25, so in quadrant 3, 24 would be the adjacent side, 25 would be the hypotenuse. And anytime I'm seeing a right triangle, I'm just going to finish by doing Pythagorean's theorem to make sure that I can get the other side. I'm probably going to need it because they gave me a right triangle. So if you remember your Pythagorean triples, this is going to be 7. And it's going to be negative because it's moving in the negative direction. Now the rest is just plug and play. Sine of a double angle. My new formula is 2 sine of theta times the cosine of theta. 2. Well, it's a good thing I figured out that other side, because sine is negative 7 over 25. The cosine, they already told me, the cosine of theta is negative 24 over 25. And I'll get 625 on the bottom. And if I just take out my calculator real quick, 7 times 24 times that by 2 now, so 336. And it's going to be positive because a negative times a negative is a positive. Cosine of a double angle. Well, look here. I've got all these cosine angles to pick from. Let's get back to the right page. I've got all these to pick from. Which one would you like to use? Well, it doesn't matter now that we know the sine. I can use this or this, but I'm just going to use 2 cosine squared a minus 1. 2 cosine squared minus 1. 2 times, well, let's come over here and take my calculator out. 24 squared is 576. And again, it's going to be positive because I'm squaring. 25 squared is 625 minus 1. Again, I can have the calculator do all that work for me. 2 times parentheses 576 divided by 625, end parentheses, take away 1. Ooh, gets me a decimal, but I know it's going to be a fraction because I've been dealing with fractions. So it's 527 over 625. Now the tangent of a double angle is kind of a cool thing. I could use the formula, but I don't have to in this case because I've got something special going on. I know tangent, based on all our identities, is the sine of the double angle divided by the cosine of the double angle. And look, I already have the sine of the double angle, and I already have the cosine of the double angle. So really it's 336 over 625 divided by 527 over 625. Okay, when we're dividing, we flip and multiply. And we get 336 over 527. Okay, here comes the math theory. I'm going to erase all these work, but I'm going to leave the answer because I want to show you what's going on. Here we go. Now, what I'm going to show you here only works on a calculator because I chose Pythagorean triple to work with. In other words, I chose nice numbers so you could understand the concept of double angles. You can't always use the calculator to cheat. So sine of a double angle. If we look right here, we could have taken our calculator and done this. Inverse cosine negative 24 divided by 25. That tells me theta is the reference angle of 163.7398. Notice it is an irrational number, so it goes on. Our calculator is just rounding. I can't round myself because I want to be precise here, but I want theta as in quadrant 3. Okay, so if that's my reference angle, quadrant 3 would be 360 minus that answer. So really, theta, the real theta we were looking at, the true theta right here, was 196.6202. Whoops. And I erased this over here. Sorry. Alright, so that's what theta is. So what they're trying to do is they're saying, okay, take theta, double it, and then take the sine of it. Well, I'm going to come over here on my calculator. That's what theta is. I'm going to double it. Now I'm going to take the sine of my answer. Hey, and if I turn that into a fraction, look what I get. 336 over 625. I get the same answer as over here. Now what was happening here? Basically, 196 doubled brought me into 392.5204 roughly. And where is that angle? Well, I go around 360 degrees, and 392 would bring me into the first quadrant. And sine in the first quadrant is indeed positive. And that's why all your answers were positive, because 392 is in the first quadrant. So cosine in the first quadrant is positive, tangent in the first quadrant is positive. And I could have done that whoops, for all of my rest of my things. I could have said, all right, well, let me get this real quick. Inverse cosine negative 24 divided by 25 gets me my reference angle, 360 minus my reference angle. 192 times it by 2. Now I'm going to take that answer and I'm going to store it to x. So, what's the tangent of x now? Hey, 336 over 527. 336 over 527. How about if I took the cosine of what I stored there? 527 over 625. 527 over 625. Now, this is only going to happen again with Pythagorean triples. If I gave you one that wasn't a Pythagorean triple, you would not get these nice answers.